Computer Science Finals Boolean Tutorial by Shaurya Kumar and Shreyas Mishra.
Table of Contents. Part 1. Intro to Boolean Logic and Operators. Part 2. Explaining Operators. Part 3. Writing Boolean Expressions and Truth Tables.
Part 4. Conclusion.
Intro to Boolean Expressions. What is Boolean logic? Boolean logic is an area of mathematics that deals with rules for manipulating the two logical values of true and false. George Boole introduced this concept in the mid-1800s. In computer science, 1 equals to true and 0 equals to false. What is Boolean logic continued? The result of the problem is decided by 3 Boolean operators. These Boolean operators are and, or, and not. There is a lesser known operator called XOR. Explaining truth tables and operators. Boolean operator, AND. When both values must be true for the output to be true, otherwise the result will be false. This is a binary operator. Requires at least 2 operators. The signs for it are as followed. Boolean operators, OR. If either one of the inputs are true, then the procedure will display true. This is a binary operator. Requires 2 operand, and the signs are as follows. Boolean operators, not. The opposite of the input. If the input is true, then it changes to false and vice versa. Only requires 1 operand. The not operation simply reverses the associated expression. Signs for not show as followed. Special character, XOR. An XOR operator is made up of and, or gates. This is a binary operator, requires exactly 2 operand. If 2 expressions are separated by an XOR operator, then exactly one of those things must be true. If neither or both are true, then the whole expression is false. The following tables show the truth tables and the symbol for XOR. What is De Morgan's law? De Morgan's law is a very important concept in programming. Failure to use this law properly causes many logic errors in programs. It basically states that the opposite of A or B equals to not A and not B, and that the opposite of A and B equals to the opposite of A or opposite of B. Simplifying Boolean expressions are as follows. Not A is greater than or equal to B is equal to A is less than B. Not A is greater than B equals to A is less than or equal to B. Not A is less than or equal to B is equal to A is greater than B. And not A less than B is equal to A greater than or equal to B.
Short-circuiting. An expression is stopped being evaluated as soon as its outcome has been determined.
Circuit symbols. These are the symbols that are used in circuits for each of the main operators. Logic gates. A logic gate is a physical device that can carry out logical operations by taking 1 or more Boolean values as input and producing 1 Boolean value as output. When talking about computers and electronic circuits, Boolean values are 0 and 1, which are binary. 0 symbolizes no current running through the wire, and 1 means that there is electricity running through the wire. A circuit is a collection of logic gates that transforms a set of binary inputs into a set of binary outputs.
These are some examples of circuits. Writing Boolean expressions and circuit symbols. These are the relational operators that we use when we create Boolean inequalities. They include greater than, less than, greater than or equal to, less than or equal to, or not equal to. Example number 1. Create a Boolean expression where the value of x is greater than 10 but less than or equal to 34. Let's take this to the whiteboard. Pause the video and see if you can do it yourself. To create this Boolean expression, we have to acknowledge each of the parts. X is greater than 10. So that means x will be greater than 10, but x will also be less than or equal to 34. To put this into perspective, we need to see where 10 and 34 will go on each of the sides of x. So if 10 is less than x, 10 is less than x, right? And then we have 34, which is greater than or equal to x. So we will put x is less than or equal to 34 here. And that's how you do it. This is example number 2, where you have to solve this circuit given by using the symbols provided. Let's take this little whiteboard and pause this video and see if you can do it yourself first. All of these values. So for A, if we keep this as 1 on this path, will stay as a 1. If we go on this secondary path, since this is a not, this will make it a 0. And then that 0 will carry down here. Then B, since that is a 1 and that is a not, this will become 0, carry up to here. And since this is an OR, 0 and 0 is 0. Now we have this OR. And 1 and 0 will make 1, and this 1 will carry down all the way until this not. This not will make it a 0. Then, when the 0 gets carried down until here, we can finally move on to C. C is also 1, so this will be 1, but this will be 0. And since this is an AND, 1 and 0 will be 0. So we carry this 0 down here. D is 1, so we make this 0 since this is a not. We carry this up here. And we also carry it down here since this is a not, so that will become 1. So now we put this 1 here. We put this 0 and 0 and 0. We bring this here 0. And we can also bring a 0 here. And then we get 1 here and then 0 here. And then for a final answer, since this is an OR, it will be 1. Conclusion. Boolean operators play a vital role in the coding world by giving a true or false definition to statements. They can be used as conditions or deciding factors and play a crucial role in decisions. These values have many different aspects through De Morgan's law and short-circuiting to the operators themselves. Thank you for listening to our presentation.